Okay, okay, okay. First step is okay. For I am only taking just one example in image recognition. So every process is like this. Okay, image. Okay, we want to train the person's image, several photos of several images of the same person by several times. We want to learn how will you identify a specific person's image. How will you identify by how will you identify the image of a specific person, or how will you identify your friend? How will you store that person's image on your memory, your brain? Is it right? Is it right? Yeah, that's the same thing happen in computer, the same thing happen in our system. Okay, the several image of same person, the several image means the training is done by the giving the same face values of the person, giving the face values of there is the okay, we have some nose value, we have some eyes values, we have some other okay chin value, we have etc, several values in our face. Okay, every person's values are unique. Okay, we should train that values into the model, and we want to create the model, and we want to test by a separate image from the same person. We can identify whether it is matching or not. That's the process of image recognition. Simple process, simple, not the deeper. That's the simple process of image processing. We have to move on the deeper session, but I will just just explain the basic of image recognition. Okay, I hope you clear what is the model is doing. Hello, what is the model? Okay, could you clear what is the duty of the model? What is the duty of the machine learning model? We can simply define as some input is to be test and create a model. According to that past data, we have to predict. We means the model wants to predict the new data. That's the output. Do you understand? Is it okay? Okay, 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 okay. Okay, here is the figure. Here is the figure. We have some model. Okay, we have some okay, we have many machine learning algorithm. Machine learning is simply simple definition of machine learning. It's automates the process. It automates the process. That is the definition of simple meaning. We have to train the data. We have to train a data. Coming to the I already discussed the example. Then building the model, then we will give a new data. That's called the testing data. First step is training with several images, and we create a model. Then we will give a new data, that is called a test data. Then we have to give the output according to our pattern. That is called, we want to identify the patterns from these training data. That is the task of creating a model. Is it okay? Okay, 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 okay. Okay. We have this is the basic and major classification of machine learning. Okay, we have three type of machine learning: supervised learning, and unsupervised learning, and reinforcement learning. Okay, supervised learning is nothing but okay. For example, just example. Okay, I am the supervisor of this class. I am giving some specific goals to you, and I will supervise to you to reach that goal. I supervise to you to reach that goal. Okay, I am giving some guidelines. According to my guidelines, you follow. That's the okay. There is a supervisor. There is a labeled. Okay, we can say the labeled data. We can say the labeled data. That means, for example, in supervised learning example, uh, we have okay. Oh, just a second. Oh, okay. we have okay, we have apple is here, and we have some other bananas. I said that apple's color is red. Okay, you might have you store that information. Apple's color is red, and apple's shape is like this. I said that apple shape like this. Okay, everything I gave you according to my information you stored, and you match that input to some specific output according to my instruction. That is called a supervised learning. Hope you clear. There is a some supervisor that there is a, or we can say there is a some labeled data. We'll see the example in later by coding. Okay, there is a some labeled data. According to that label, we can match the input to some output. Clear?
Yes.
Okay. In unsupervised learning, there is no labeled data. Okay. There is no supervisor. There is no supervisor. Okay. This learn from the several time of self training. Okay. This type of algorithm learn itself. You can say this type of algorithm learns itself. Is it clear? Hello.
Yes.
Okay.
Yes.
Okay. The next type is reinforcement learning. Like, okay, for example, okay, I will give you an example of reinforcement learning by you can simply understand. Reinforcement learning is nothing but okay. You might have know the chess game. Is it okay? You know chess game. Okay. Okay. How will you learn the chess? How will you learn the chess game? Okay,
How do you learn
by play chess
chess?
by
Yes.
yeah
Yes, they want to
by
respond.
okay.
Good. Yes, can you speak louder?
We first have to learn the rules of the chess.
You first learn the rules of the chess.
Yeah. Then okay. Then play the several times, right? Play the several times,
Yes,
and
yes.
and uh, and we can okay. I will explain. Okay. We just learn the rules and we play the several times, and we understand that step, each and every step. Okay, how the negative and positive step we might have to know by trying by playing several times. There is no one single step, no single step we can understand the whole game. There is a combination of several steps to win. Is it right? There is a combination of several steps. Okay, there is a positive type of learning and a negative type of learning, because we make a move and we win that game. That is a positive type learning. We can understand that move is good, that move is better, that move is leads to win. Is it right? Then we learn that move. Hello.
Yes.
Okay, if I take a move that loses me, then I can realize that move is negative for me, that move is leads to failure. That So we can learn from two type for once first from positive move, and we have negative moves, right?
Yes.
Yeah, there is a okay, in chess game there is a combination of, there is no one single step. You must understand that there is no single step, there is no single step learning. There is a combination of learning procedure that's called reinforcement learning. There is a negative, from the negative movement, and the also the positive movement. We can learn from the negative movement as well as from the positive movement. Is it right?
Yes.
Okay. Then we can move on to the supervised learning and their algorithm. Okay. First, okay. I already explained what is supervised learning. Supervised learning is a type of machine learning method in which we provide some labeled data. I already said what is the labeled data to the machine learning system or machine learning model in order to train it. First step is training, very important. We want to train the model. We want to train the model. Training is nothing but okay, like human being, how human being is capture a data or store a memory by seeing or by perceiving several types of same thing. Is it right? How will you identify your friend? You are seeing the several time of his faces or something like that. Then you store his face into our memory, our brain. That's the same way we train. We give the several. We give the image or something etc. data in several time and train and create a model. Okay, that's the basic thing. And it predict the output based on this trained data. That is the supervised learning. We have two classifications, two major classification. First one is classification. Second one is the regression. Two major classes are there in supervised learning. First one is classification. Second one is regression. Okay. Okay. In classification algorithm is nothing but it gives some classes like yes or no class or zero or one class or spam or not class. Okay, something we have. Okay, just look here, just look here. Okay, we have a lot of data. We have lot of data here. You can see the circle, and we can see the triangle. Okay, he here before this is the output. This is the output graph. Before that, we have some unlabeled. We have some mixed data here, and by using the classification algorithm, we can convert that data into these two class A and B by using some pattern. This is the pattern of this data. Okay, here is the square, here is the circle. Okay, this classification algorithm classify the data by similar pattern, by identifying the patterns of data. Is it clear? Is it clear? Okay, this may have one or two classes, three classes. That doesn't matter. Okay, we have categorical. You must notice that we have the categorical data, not the numeric data. We have only the classification algorithms output is categorical data, either yes or no or zero or one or spam or not spam or cat or dog. Okay, we'll see later. Okay, example. Okay, only the categorical data. You must notice that the algorithm classifies into classes by categorical data. Is it clear? Not numeric data. Fine.
We lost.
Okay, okay. Then we have two classifier. We have binary classifier. Binary classifier is done by is the classification has two possible outcomes like yes or no, male or female, spam or not. Okay, this example we have here the values of male or female, etc. Okay, we can classify that data into male or female. That's an example of classification. And we have multi-class classifier. Okay, more than two classes. If there have more than two classes, we can say it's a multi-class classifier. I hope you clear binary classifier and multi-class classifier. In binary classifier, there have only two classes. In multi-class classifier, they can have more than two classes. Is it clear? Okay, fine. Okay. Okay. Okay, we have some classification algorithm. We have some classification algorithm. There are we can classify into we can divide that classification algorithm into two major steps. First one is linear model. In linear model, we have logistic regression and support vector machine. No, in non-linear model, we have KNN, K nearest neighbors, kernel SVM, kernel support machine, naive Bayes algorithm, decision tree classification, random forest classification. These all are the algorithms, classification algorithms. These all are. Okay, we can move on to first logistic regression. We have several type of classification algorithm is there. Okay, first one we move to the linear model logistic regression. What do you mean by regression? My first question is what do you mean by regression? What do you mean by regression? Okay, I just give an example, simple example. Okay, I say that just a mathematical problem. Okay, just as a logical problem. Is the logical problem 1 equal to 5? Second one, 2 equal to 10, and 3 equal to 50, 4 equal to 20. Then I will guess, I will say 5 is equal to dash. How can you identify the value of 5 in regression? Is logical method. First one is equal to 5, 2 is equal to 10, 3 is equal to 15, and 4 is equal to 20. What is the value of 5 in this model? Can anyone say?
We are multiplied by 5.
Yeah, I can audible. Can audible.
85.
25. Yes, right. How will you get that 25 value? How will you analyze and get the value? You you should follow some pattern, is right, before identifying the past data which I have given. Is it right?
Yes.
Yeah. Then you predict the next value. You predict the next value. That's the process behind that prediction. Is it right or not? Is it right? You analyze the past data and predict that new value. Hello?
The question is based on the example that he gave. Is it possible that he can use data to predict the next value?
Yes, possible.
Okay. That is simply means regression by analyzing the past data and predict the new data. That's the regression. Simply we can say the regression. We have to analyze the past data and we want to predict the new data according to our previous data. That is called a regression. Is simply. Okay. Hope you clear. Okay, we have several regression algorithm, lot of regression algorithm we will take in regression section, but the logistic regression is the classification problem algorithm. You must note that logistic regression is used to identify the patterns in classification problem. Okay, logistic regression is a machine learning algorithm which is used to the classification problem, not the regression problem. Majority is in the classification problem. That is the important point is here. And it is a predictive analysis algorithm and based on the concept of probability. What? It is the predictive analysis. Okay, analyze and predict. That is the basic idea of regression. Hope you clear. Hope you clear. Okay. Here the next point is it is used to predicting the categorical dependent variable, not the numeric data. Categorical data. What I say in classification? Classification is all about the categorical data. Hope you clear. Not the numeric, not the single numeric data. Like okay, we can see in the example by code in regression session. Okay. Here logistic regression gives the categorical data is fine. Hope you clear that point.
Yes.
Okay. Logistic regression predicts the output of categorical dependent variable. Therefore, the outcome must be a categorical or discrete value. It can be either no, yes or no, 0 or 1. Same in the classification we have discussed above. Okay. Next. Okay, here is the difference between linear regression, okay, and simple regression. Okay, linear regression we will discuss in regression session. Is the method of regression. Simple linear regression, simple multivariate regression we have to discuss by using code. Here we can see this is our task is that we have to move this linear regression to the logistic regression. Okay, what is the disadvantage of linear regression and linear regression is that we have to the some data points must be become an outlier, become a noise. Okay, some data points must be in mismatching in linear regression. By using logistic regression we can deals that mismatch, we can avoid that mismatching by using logistic regression. Hope you clear. We can
Yeah.
avoid that mismatching, mislabeled data by using logistic regression algorithm. Hope you clear.
Yes.
Okay, we have a graph like this in logistic regression. We have
Let,
hope
let, let
you.
me let me ask them whether they do understand. Do you really understand what he's saying in terms of simple linear regression?
Philip, sir,
You don't
Philip, sir.
understand, you say you don't understand.
Hello.
That clear.
I will.
You don't say you
I will.
understand while you don't understand. Yes. Yes. Can you can
Okay, I
you
will.
can you continue and clarify that?
I will.
Yes.
I will explain simple linear regression in later in the regression part. This is. I will explain again with code.
Oh, okay.
Okay. Okay. Okay.
Continue, sir.
Here only we have discussed about the logistic regression. In simple linear regression, we have some mismatched labels or matched data that we can avoid by using logistic regression. We have here we have in simple linear regression we have a activation function. What is the activation function? We can see the activation functions in by using code. Okay, we have some activation function like this y of x. Y means independent. Y means okay. In y axis we put the dependent variable. Dependent. There is a two type of variable. Okay, what is the dependent and independent variable in above which example 1 equal to 5, 2 equal to 10. Okay, we can classify that two data into dependent and independent variable. Okay, the same like we have two type of variable, independent and dependent variable. Okay, dependent variable we put on the y axis and independent variable we put on the x axis. Is it clear?
Okay. Can you go to the last slide? I want to explain something to them so that at least they understand.
Okay.
Can you go? Yes, thank you. Yes. What he's trying to say is that if you have a set of data, you understand? So you want to, that is the regression problem. So based on the similarities on the different data sets, so you're going to use the linear regression for the hour of an hour. Yeah, category thing. You will have a category thing. You will have Masha, I know about all of an hour. Okay, you will see here. Then I guess we are in a system. You understand that? So we are going to use the linear regression to go back. So, however, this is the line. It's like a so with this line, it will going to the home from the use as square. Then I take a one as square. You understand that? So when I set up the line, so then I have read over now. It's either use square markup. So since you are training your model, this is kind of a supervised learning. So our program is classified 100. So you need to do some steps, which is going to explain. Is that clear? Yes. So with this I think is going to explain this. Come further now. This is like you say, it uses the mathematical concepts to when you're building the model, you are using the mathematical algorithms to do that. So how I was okay, fine. Based on this, I back in the with like I'm on a tap you want to come. So in general, Italy goes this is what you call the threshold. It's either like a class cap, like a so this is just a simple question. Yes. Thank you. You can continue, bro.
Okay. 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 Okay.
Yes.
Okay, we have linear regression. There is an activation function y of x. Y means that independent variable according to x varies according to x value. We have m x plus c. Where m and c some constants we will discuss. We can see in our demo session. And in logistic regression, we use some sigmoid function. Sigmoid function is nothing but y of x is equal to 1 divided by 1 plus e raised to minus x. You might have seen this sigmoid function, I guess.
So you continue.
You
When it comes to those mathematical calculations, we don't go much into details since
okay,
these are
okay,
still
okay,
the
okay,
undergraduate. So
okay.
you just
This is okay, 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 fine. Okay, we can see how sigmoid function and how activation function helps this model. We'll discuss. Okay, here powers is getting off. Okay, can I stop my scam? Is it okay, Philip, bro?
yeah,
Can I?
it's okay, no problem. You can stop right
Okay,
there.
okay,
No
okay.
problem.
Your power is getting off. There is some problem. Okay, okay, okay. And in logistic regression, okay, in logistic regression, the y of x is sigmoid function. Sigmoid function. We can see what is sigmoid function. How the mx plus c used in linear regression later. We have a demonstration in by coding. Okay, okay. You must understand that there is two type of function. First one is y of x is equal to mx plus c that used in linear regression. By coming to the logistic regression, I have already said that there is some advantage in logistic regression. We have to give some more good output in logistic regression. That's by using this activation function y of x is equal to 1 divided by 1 plus 1 plus exponential e, okay, power of minus x is used in logistic regression. Okay, okay, that function is called that activation function is called a sigmoid function. The sigmoid function is used in logistic regression. Okay, here is the sigmoid graph. Here is the graph. The sigmoid is deals with that. We have this sigmoid function map that data, the actual raw data, into the data between the interval 0 and 1. That is the duty of sigmoid function. These sigmoid functions convert the original numerical data, raw data, into the 0 and 1 interval. Okay, see the data between the 0 and 1, the 0 and 1. Hope you clear. What's the duty of sigmoid function?
So it simple means that we use, if we have a set of data that is coming in, so we use sigmoid function to convert that from the range of 0 and 1. So that is the work of the sigmoid function. That's just what it's trying to explain. Yes, continue.
Okay, okay, fine. No, just a second. Then we have k nearest neighbor algorithm. K nearest neighbor algorithm. Okay, what is k nearest neighbor algorithm exactly do is that the k nearest neighbor algorithm is a simple supervised machine learning algorithm. Okay, this is a non-linear type. I have classified here. We have linear type and non-linear type. Just a second. Okay, we have linear type and non-linear type. Okay, the k nearest neighbor algorithm is in non-linear type. Non-linear type. This is also a machine learning supervised machine learning algorithm. Okay, just a second.
So can I
It's a
just
supervised
clarify
machine
something
learning.
over there?
Ah,
Yes. So to say that
okay.
it's, let's say it's one of the algorithms that is the linear regression. How does she get that line? Like one line between that is lean. Yes, that's why it's called linear regression. So now we're talking about non-linear. There are some situations whereby you find that you need to classify your things. But if one homo, they don't need that straight line. Or if not classify, so that's why it's getting into the non-linear algorithms. Yes, continue.
Okay. This is the k nearest neighbor algorithm is a non-linear type, okay, which is also a supervised learning algorithm which is used to solve the classification as well as the regression problem. But the classification, the k nearest neighbor algorithm is used mainly in by solving the classification problem. Okay, this is very easy method. This is very easy method. It is nothing but we have some data. We have to train this data. We have here is a we have some data set like animal. We have, okay, then we want to train data. We want to train the images of these animals picture, and we want to identify which is the which class. This we will give a input of cat. Okay, I will give an input of face of cat. Okay, then this cat, we want to identify this cat, this cat is going which class is belongs to this cat, whether it is cat class, we have dog class, we have other animal class. Then how will this cat will goes to the cat class? That is the important thing to identify in classification, so in knn algorithm. I will going to explain how this works. How this works. We can, okay. Here is the input value. This is a cat, and the KNN classify. This model gives the output. This is in the cat class. How this works? How this works? That is the question. Okay, this by using KNN classifier. How the mathematical algorithm, how the KNN source we can see here. We can see here. We have here. You note that here we have some data. We have some data. Class A and class B. This is cat. This is dog. You must okay. You assume that this is category A is cat and category B is images of dog. Okay, okay, we train the category features of cat in and features of dogs. Okay, then we separate that class in some classification algorithm model. Then we give a new photo, new images of cat, or we give a new images of dog. Okay, I will give an input. I will already shown that's a machine learning workflow. First train the data, then create a model. We already created model. Then I give the image of cat. Okay, this, okay, for this blue is the new input of my okay, this data point, this point is closer to near to the green data. Is it right or not? Near, the distance between green data point and this blue data point is smaller by comparing the distance between orange data and blue data. Is it clear? Is it right? The distance between class A,
Can I,
category A to, hello?
yes, can I explain something over there
Okay,
so
okay,
that they can understand?
okay, okay, fine.
Yes, for you, if you want to understand something, you'll always ask the lecturer to explain in Malayalam. So also I have to
Okay,
explain. So
okay, okay,
exactly
fine.
right.
No problem. No problem, bro.
Yeah.
No problem. No problem.
So that only goes at home. But I don't want the two different things. They are being layered cards. You understand? Maybe if you haven't got this data, I can feed that into our models, just the KNN. So even in learner all the features that cat, in learner all the features that dog. Yes. So how can I with the even you use something like this? Even you are cool. Kan kena mfumo katika kuanza bele inja kan kena ele ili kazi ya bisa. Dan ilo toshe mahona. Okay. Ona le enyo data form. Eta mfumo sana le enyo data set. Sana toshe mahona. Ha data set data encha esa solution for train the model. Ile encha batang ko na model ko ko classify data ya mo ko ka ngati. Ka bisa. Dan hai data toshe mahona. Data eta if you are this category, if you are this other category, now we say it. Happy child that you didn't allow it, you can that's about the care. That is it. So, thank you, bro. You can continue.
Okay. This, okay, distance classification. We have some method in mathematics. We have to calculate the distance between these data points by using Euclidean distance method. Euclidean distance. You note that method, Euclidean distance. By Euclidean distance, we can calculate this data point, this new input point to every other data points in our data set, and the shortest distance between, okay, two class. Okay, this point we want to identify which class labels have shortest distance to this point. Then that data point is entered to that shortest distances class. Is it right? We find the
Yes.
distance between every data point, and the smallest or shortest distance is shortest distance class is accept this data point. Is it right or not? Here we
Yes,
can
correct.
see after by using canon, after we can see this blue data points belongs to this green category, this category A. We can catch this distance by using distance, Euclidean distance. Is it, hope you clear?
Have you done that in statistics? Euclidean distance. Yes.
Statistics.
Euclidean, yes, in statistics. Yeah? Euclidean distance. Like algorithm, yes, to measure the distance. Yes. Yes. Hmm? Yes, that's what I'm saying. Brilliant. Perfect. You can continue.
Okay.
Yes, I was asking them whether they have done this in statistics, like the Euclidean
Uh,
algorithm to calculate the distance.
sorry.
So they are saying that they have done that. Yeah.
Okay. Here we have the Euclidean distance equation. We have some equation. Here is the equation root of sigma 1 to k xi minus yi whole square. Okay. We have here the data point value and the y value and x value. Okay. I told you already there is a x and y value. Okay. We have to calculate this distance like this distance. Okay. Etc. N number, k number of data points is here. We want to calculate the k 1 to sorry 1 to k, okay, all the distance between all the distances from this point to all other points in our data set. Then we have to match that data point into smallest distance class. That is the idea behind k nearest neighbor algorithm. Nearest neighbor is nothing but the near, very closer value between these data, near, very near value, then match it to that class. That is the basic idea of k nearest neighbor. Is it fine?
Okay. Can I explain? Nthabe ka ngwe hlalosa ke a bona. Hore re tseba hore na a new data point e tla. Hore re tseba hore na e haufi le which category. Ba tlo sebedisa Euclidean algorithm to do that. E leng hore each and every point that comes in, e tla comparewa le tsena tse teng kaofela tsona. E le hona ho determine hore na is it near category A or near category B? Then, based on the distance in between, that's when can we classify it in category E or category B? That's what he's trying to say. Is that clear? Yes, continue, sir.
Okay. Here k in kn, and k is nothing but it is a parameter that refers to the number of nearest neighbors. Okay, k means the number of nearest neighbors in this point, the number of nearest neighbors. That is the k here. Okay, the number of nearest neighbors to include in the majority of voting the process. Okay, that means k means the number of neighbors in this data set. Okay, we can calculate the k value. There are several steps by calculating the k value. We have some mathematical equation by calculating the k value in k nearest neighbor algorithm. That is k is equal to sqrt of n nothing but the number of data points data in our data set. That is n. Or we can choose k is randomly by the smallest value like 2 or 3, etc. There are several methods. In the mathematical method is fine, and the finest method is k is equal to sqrt of n. Is it clear? Calculating the value of k.
Yes.
Okay. 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 Then pros of KNN. Okay, this is simplest method, very simplest method, and flexible. Okay, or the distance choice. We can calculate the distance, very simplest method. Okay, and handles the multi-class classes, and can do well in practice with the enough representative data. We have practices with the enough representative data. Okay, and cons of Canon is that demerit of Canon need to determine the value of parameter k. We want to this is if okay. I told you there are several methods to determine the value of k. There are several methods, but that k is not mandatory to correct the k value is we cannot say that k value is the proper k for that data set. Okay, the identification of k is little bit difficult. That is the disadvantage or demerit of k nearest neighbors algorithm. Is it clear? And the computation cost is high. Okay, you must heard about the computation or time complexity, like that is data structure and algorithm. You might have heard about time complexity of several algorithms. Is it right? Time complexity.
Yes.
Have you heard about time complexity or in data structure and algorithm? You might have heard or might have learned the time complexity, the computation complexity. Okay, okay. I guess I hope you heard about, you know about the time complexity or computation
Yes,
complexity.
they are familiar to that. They know.
Okay,
We have
okay.
done
Now the
it.
computation, okay, the computation cost or time complexity is high. Okay,
Yes.
this need a large storage, large storage. Okay, then must know we have a meaningful distance function. We want to a meaningful. We want to a distance function. Okay, otherwise we cannot handle this KNN near k nearest neighbor algorithm. Okay, in summary I can we can say the k nearest algorithm is a distance based method. Okay, we have training data and testing data. Okay, we train the data first, then classify, then category, then classify or divided to that data into separate classes. And the model, after the creation of model, we have to give a input data. Then we find the distance between every data point from every data and point, and that new data point is matches to the smallest distance class. That is the KNN is in short. Is it clear?
Yes, it's clear.
Okay. Okay, in computer you must have noticed that we can identify. Okay, for example, here is the combination of mangoes, here is the apple. Okay, we can, okay, I'll give an input of apple. Okay, we can understand simply this apple is belongs to this class. Okay, we have know what is the shape of apple, color of apple, etc. But in computer there is all in mathematics, there is all their identification all about mathematics. Okay, they can compute all the mathematical functions and matches to that class. Is it clear? All in mathematics, all models are built in mathematical equations. That's I am saying every model have some equations. Okay, we have seen in sigmoid function, we have seen y is equal to mx plus c function, we have seen here other Euclidean function. Okay, there is a mathematical functions in every machine learning algorithm. Is it clear?
Yes. So what he's trying to say, now some of you are why do you put that? So you cannot build the algorithm from the scratch if you don't have a good mathematical record. Because all the models are built based on your mathematical skills. So to start the model from the scratch, you need the mathematical background. Yes. Yes, I think you can continue.
Okay, okay. Oh, Philip,
Yes,
sir,
seems like,
how many hours
seems
left?
like we
So
are.
how many minutes
Sir,
left? How many minutes
um,
left?
yes, when do you think you can finish this?
Okay, I think I want to half an hour. Can I continue in half an
Uh,
hour?
I think it's too much.
Is
We
it
have
fine?
only maximum 30 minutes now. Maximum.
30. Okay, okay, okay.
Yes,
30 minutes.
maximum 30 minutes. Yes.
Okay, okay, okay. Fine, fine, fine.
Good.
30 minutes. Fine.
Good.
Okay, okay.
Yes.
Here is the
So what
algorithm.
you can do, you don't need to go like wherever you have to explain the mathematical concepts
Okay, okay,
behind different functions. You don't need to go
okay.
into details. You just tell them that,
Oh,
oh, this one we use this function to do this.
okay,
So we
fine,
are
fine,
more
fine.
interested. So they don't need that mathematical part of it for
Okay,
now.
fine, fine, fine. Okay, fine, fine.
Yes, so that we
Okay,
can move fast. Thank
okay,
you.
okay. Okay,
Good.
welcome, sir. Welcome, sir. Okay. Okay, we have the steps in k nearest neighbor algorithm. First one is I told you select the k number of k by using the mathematical functions, or randomly we can choose the k. Then calculate the Euclidean distance of k numbers of neighbors. We can calculate the Euclidean distance. Then take the k nearest neighbors as per the calculation Euclidean distance. Then among these number of k, next step is among these k neighbors, count the number of data points in each category. Okay, we have to count the data points in each category. That is nothing but I will okay, that is nothing but we have to we here we have a point, we have a new data point, we calculate the distances between these all data points. Okay, we have here these are the neighbors of, we can see, okay, we can simply randomly we can say these are the neighbors of this data point. In class A we have three neighbors, three or four shortest neighbors in that this data points to this class. And by coming to this class, we have only two data points, two k numbers, two data points of neighbors of this data point. Then we can say by result, by output, we can say here we have k is 4, here we have k is 2. Then that data point is matches to this class. That is the working of k nearest neighbor algorithm. Is it clear? Is it clear?
Good.
Count the number of data points in each category. Then assign the new data points to that category for which the number of the neighbor is maximum. I told you here is the I told you just a second. Here is the in green class we have four data points. I randomly say here we have 1, 2, 3, 4 data points to nearest data points to this data, and here we have two data points to this data. Okay, then we can finally we can count four from here, two from here. At final result, we can classify this data point into this class because we have more number of k from category A. Hope you clear. Hope you clear.
Yes, perfect.
Okay. 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 Fine. Then we have already we discussed what is regression. Okay, in what the you must notice that the regression and classification is two type of supervised learning algorithms. In regression, the regression gives the numeric data, output is some numeric data, not like categorical data. That is the major difference between regression and a types. Okay, I will give you just I give you example. Okay, we have you imagine that you are working in a company. You have in what is your sir hello sir
So,
hello
yes,
hello uh,
Yes.
hello
we can hear you.
what
No
is your
problem. Continue.
like okay you have dollar what is your currency
The
your
currency, dollar.
currency name
If-
dollar.
Oh, our currency name is Maluti. Maluti.
Magnitude, okay. Suppose okay,
Yes.
okay. Suppose you imagine that you have okay 1,000 maluti in 1 year. Sorry, okay. In the initial stage of your joining the company, and the company increment, okay, 100 malutis or $100 in every month. Okay, every month. Okay, by analyzing that data we can predict the salary or we can predict our future salary after 5 years by using the regression analysis. That's the numeric data. That prediction is belongs to a numeric data. Your salary will be a numeric data. For example, 10,000 maluti or lakh of maluti. Okay, is it fine? In regression we have numeric data. In the output, the predicted output is numeric data, not categorical data. Is it fine? Is it clear?
Yes, perfect.
Hello? Okay, here is the example. We can predict the age or we can predict the temperature. Okay, you want to buy a house. Okay, we can see an example in code. Okay, we have to I will say there is four bedroom, there is one kitchen, there is one sit out or everything step etc. Okay, this amount is something this. Okay, and other houses for example three bedrooms according to that feature that feature we given that price is decrease or vary or increase or vary. We have to predict the price of, we can predict the price according to that variation by using the prediction algorithm like regression algorithm. We can predict the price of houses, okay, the house, or predict the price of vehicle, or predict the price of anything other by using the regression algorithm. Is it clear?
Yes.
Is it okay? Okay, fine.
Yes,
We
it's good.
have several, okay, we have lot of regression technique. Okay, we'll discuss today only linear regression and a multivariate regression. This is the basic regression type. We have to move linear regression. Okay, sorry. Here is a linear regression. Is some spelling mistake. Linear regression. Linear regression is nothing but the statistical regression method which used to predict the data. Okay, here in linear regression, there have only the one dependent data and one the independent data. Okay, we have to map that data, independent data to dependent data by only analyzing the single variable. For example, okay, uh, I can say, okay, the price of the house, okay, price of the house is according to only the age of the house. Okay, if 5-year-old age house is has some x value, x price, and 10 aged house is some other y value, we can predict the value according to only single variable. And multivariate regression is nothing but we can predict the value or predict the output by using several data. For example, number of bedrooms, kitchens, and the square feet, houses age, or houses facilities, other facilities. We can predict the value according to several attributes. That is the difference between multivariate and a single variate, simple linear regression and a multiple linear regression. We can, in simple linear regression, we can predict the data by using single attribute, and in multivariate or multiple linear regression, we can predict the data by using multiple attributes like bedroom, number of bedroom, kitchen, square feet, age of house, etc. Is it clear?
Yes.
Is it clear? Okay, here the simple example of linear regression. Linear regression, only here we can take the attribute is experience. According to experience, the salary is increasing. Here, experience is the x-axis, and a dependent variable. Dependent variable is y. Okay, according to the experience, the salary of the person is increasing. According to here, salary is depending the experience. Is it right? Salary is depending experience. Here, salary is dependent variable and experience is the independent variable. This is a linear regression. Clear? Clear? Okay. In
Yes.
multivariate regression, by using this experience, we have also other attributes in z-axis, like we have experience and the performance of that specific person. We have to increase the salary according to the performance also. Okay, we can use performance is an attribute, experience is an attribute, or education qualification is another attribute, etc., etc. We have used multiple attributes in prediction of salary. That is multiple linear regression or multivariate regression. Is it clear? Is it clear?
Yes.
Okay, here is also, okay. I told you in regression we use an equation y of x, that is independent variable, okay, equal to mx plus c. Here y is dependent variable and our target variable, x is independent variable. Here experience is independent and salary is dependent variable. We can see here experience is depending, sorry, salary is depending the experience. Okay, we can see here y is dependent variable. Okay, here is the salary, y is the salary. According to the experience, we can increase the salary or decrease the salary. This is a salary prediction. Is example of regression.
Okay.
Okay,
Okay.
sir, can we?
Just a minute.
Okay,
Just a minute.
hello.
What
Okay.
that is? this is very important. You need to understand when you are building the model, you have to understand which are dependent variables and the independent variables. Is that clear? So what if you the application in manner which are the independent variables in terms of so based on the experience and other attributes, governor salary hike availability. So you need to understand which are the dependent variable and independent variables. Because that is the most important, that is the core when you're building your models. Is that clear? Perfect. You can continue, sir.
Sir, can I share Jupyter notebook here? Jupyter. We want
Can
to.
you
I want to. Can I share Jupyter notebook here? Jupyter
Jupiter?
coding.
Yes,
I
yes,
want.
you can.
Yeah. Okay.
Oh,
Just wait. I want to implement
can
by
you try? I
using
don't know
code.
whether you can share the screen or
Okay.
something. Yeah, can you
Okay.
try?
Okay. Just wait. Just wait.
Are we still good? Yes.
Okay.
I
It's
know
good.
you're
It's
tired.
good. It's loading. Loading.
Yes. I know you're tired.
Okay. Can you see my can you see my Jupyter screen? Is it okay?
We can see. Let me add it to the screen and remove this one.
Okay.
Yes.
Okay. 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 Sir, could they familiar with Jupyter or coding section
What
in
I say?
Python? They familiar?
Yeah, yeah,
Could they familiar?
yeah, yeah,
Yeah.
yeah.
Okay.
Using Python.
Uh,
Good.
Okay.
Great.
We have here some data. Okay, I want to predict, my task is that I want to predict the price of house according to area, bedrooms and age. Okay, I want to predict the house of the price. That is my task. I have some data set. Here we have 2,500 and 3,000 etc. We have some area of house and the number of bedrooms is here. Here you can see is a NaN value, that is missing value. That is the you might have learn you or you will be learn the missing value or unwanted data or outliers in future classes. Okay, here, okay, I will explain how to remove this NaN value all etc in our coding section. Okay, we have number of bedroom here, 3 bedroom in first home and 4 etc, and age according to here. This is 8-year old age and 4 year etc like that. And I want to predict the price according to this data set. This is my training data. I want to train my model by using this data. This is a simple example. Okay, hope you familiar. The data set is clear. This is the CSV file but is used in my regression, my multilinear regression method. Is it clear? All data set is clear, I hope. Hello?
Yes,
Is it
it's
clear?
clear.
That okay.
Yeah.
Okay. Okay. I have. Okay, fine. Multivariate.
I think you can go straight to where you have
Okay.
built the models and
Okay.
explain it from there so
Okay.
that
Okay.
they
Okay.
can understand how do we build the models, all
Okay.
those
Okay.
steps
Fine.
which are necessary. I think this
Okay.
part will be enough for them for today.
Okay. Fine. A coding part is
Yes,
not
perfect.
for. Okay. Fine. Okay.
Yes, you
Okay.
can
Then we
just
can.
show that note. Great.
Okay. Fine.
Yes.
Okay. Okay, just I want to clarify some that uh, uh, equations like sigmoid and mx plus c. Okay, we have, okay, just I only one point from here. Okay, I am multiplying here. You can see in this line. Here you can see there are some constants values. So there are some values that build the model by using these Python libraries. Already we have some models, we have some ready-made models, and at last the output you can see. I have these data points. You don't focus on the code, only focus on the focus on the theory part. We can see here some data area and according to the price. This is the data which I give to train that model. This is the data, and I give a new input like we have here. You can see at the code 49 we can
Okay.
see
Can I
represent.
come in, sir?
Okay, okay,
I think on this part is the most important part. I think
yeah,
you can start from the libraries and
okay,
how
okay,
did you import the data set and everything. You can just start from there, then you continue.
okay,
That
okay,
is
okay,
important, like
okay,
step by
okay, that,
step.
okay, step,
Great.
okay, fine, 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 fine. Okay, 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 data set is clear. Uploading data set is clear. Is it okay? Uploading data set is clear. We have in Python Jupyter node, we have here upload function, and we can upload that data by here data from we have already created some CSV file and upload. It's simple. Okay, then we use some libraries. It's like pandas, numpy, sklearn, okay, etc. Pandas is a library for reading that CSV data file. Here you can see in you can read a data in C language or other language. You can use C in or scanf like etc. You might have know the language of C and C++.
Yes,
Is
yes.
it okay? We can use C in or scanf in C or C++. Like that, we use PD or pandas library. The PD is the data. PD is the object to read the CSV file. Reading first, we want to import the CSV file and we want to read that CSV file by using pandas. Is it clear? Is it clear?
Yes.
Okay. Df is the object. We can just put df itself or print in Python, print df. We can specify in an df is gives the first five row or first some rows of our data set. We have 5 rows and df is we can see by printing that df that CSV file is stored into this df, and we can see the df file here, df data here. Clear? Clear?
Great.
Okay, then here we next line is okay, next line the okay, we I call that function bedroom dot median is the mathematical statistical function. The use of median is here that we have a character data here. NaN means if this is a error or this is a outlier. We can say error or outlier. Okay, I want to replace the data with the numerical data. For that, I want to find the median of this all data, and that I give the 4.0 here. Is it clear? And I fill that data using fill NA function. Fill NA function. We can see that NaN value can replace it with the 4.0 here. Is it okay?
Okay. Can I explain that?
Okay.
Yes. When you take a look at this data set, when I look at this now, it means the bill that was supposed to come here in terms of the bedrooms is not known. Is that clear? So, I want it's numbers like it's 3, 4, and so forth. So, for us, we don't know which number should come here. So, there are methods that are used to replace the null values. You don't just put any number here, because if you put any number, it can affect the results of your data. When I get the we build the model based on this data. Since you just any value, you put it here, or you leave this place as null as it is, it might affect the results. You understand that? You might find there is a figure here that is supposed to be the number of the bedrooms. Maybe they are 50. You understand? We don't know that. but there are ways that you use in machine learning to replace the null values. So the book that I gave you for data mining, so you can use that book to see that if we have null values, what do we do? That is part of the data cleaning in the stack. That book. Is that clear? Great. Yes, you can continue.
Okay, then we have a function, okay, linear regression. This is a package for implementing our regression, linear regression or multivariate regression. We use some sklearn library, then import that linear model. This is a ready-made model already built data machine learning engineers. We can just call this model by using this line of code. Okay, we can import from sklearn this linear model. Okay, fine. Okay, then I want to import that linear model. Then I want to train. Okay, sorry, here just okay, just here I want to here this is a function. This is a function. Here I have a area, bedroom, and age. According to this is the multivariate regression. We have three three variable, three attributes, and we want to predict a price. Is it clear? We have three in regression model. We have three attributes. According to these three attributes, you can analyze here. We have 2,000 square feet and three bedroom and 8 years old. We have something this price, and according to the area increases, the price is increases. According to ages, it decreases, the price is increases. Uh, that is the pattern. That is the pattern to identify here. We have to identify that pattern from this model. Is it clear?
Yes.
Do you
Is it
understand?
clear?
Liao,
If you want to identify the model, want to identify the pattern.
can I explain that?
Okay, fine. Okay.
Yes. What he's trying to say is that however, there's features that we have here. We have feature number one, which is this one, the second one is this one, and the third one is this one. So based on this feature, we can be able to predict the price. How this is again. So we already have three features. We already have the prices. So what we are going to do, we have already imported the model, the regression model. We take the data that is here. Data has this first attribute, second attribute, and the third attribute, and this last attribute, which we may want to predict. So we use this data to train the model. So the model is going to learn the patterns within this. If the area is this much, and the number of bedrooms is this much, and the age is this much, then the price is this much. If the area is this much, and the bedroom is this much, and the age is this much, then the price is this much. Do you understand? So once the model has learned the patterns from this data, then if we bring the new data, that is the test paper, he is going to explain that. He's going to be able to predict or now what's going to be the price. If we give the model the data actually just the three attributes, we found the price. So the fact that the model has learned the patterns from the previous data set, then can be able to predict what will be the price. So that's what he's trying to explain. Is that clear? Perfect. Yes, you can continue.
Okay, then we have other two variable. I already said that we have y is equal to mx plus c, the mathematical equation. There is some m and there is some c value. Okay, here is, we can say this is a coefficient. We can say m, y is equal to, y is the independent and x is the dependent variable. Here we have several x's here. Area is a x1, bedroom is x2, and age is x3. Here the mathematical, and according to these three data attribute, we can predict the y value. Y, that means the price value. Okay, in price value, by predicting the price value, we use some coefficient m and c in our equation. We had seen already m and c. This is the value used in this linear model. This is the value of m and c here. Okay, you can just typing the reg dot coef, we can see the value of m, and intercept means the value of c here. Okay. Okay, this is the mathematical function. This is the mathematical function to use in linear regression to model, to label the exact output. We have to label. That's the duty of supervised learning, to label from some input to some output. Okay, that by using that to model, to creating a model to matching the correct output, we use some coefficient, and we use some other constants values that is already defined in this library. Okay, hope you clear. We have to see by giving this command, we can see what is the value of m, what is the value of c are used in here. Clear? All clear?
So the value of C and the value of M, they comes from that equation that he showed you earlier. That is y is equals to mx plus c. Do you understand that? Yeah, C is coefficient. Do you understand that? Great. Yes, continue, sir.
Okay. Here we have 3x, x1, x2, x3. Here we can see, just check here. We have some data x1, x2, and x3. According to this x1, x2, x3, we have to have y value. Here we use this value, this m into x1. Okay, 57.3 some m value, m1 value to x1, and this value to x2, and this value to x3, and we have to a c value here, c value plus c. This is the equation y is equal to mx plus c, or y is equal to m1 plus x1, m2 plus x2, m3 plus x2, up to etc mn plus xn in multivariate regression. Hope you clear.
Yes, that's better.
Okay.
So
According to this
what is
value.
trying to explain here? Yes, can I
Oh, you can continue, sir. You can continue, sir.
yes.
You can continue.
What is trying to say based on the formula? He is trying to explain how now. How to repeat this value here. I coefficient formula mx plus c. So the combination of the three is also of this one. Is that clear? Yes. That is the formula in the equation. Great. You can continue.
Okay. Then here I already trained this value. And you can see here. Here the value is 41,000. 4105497 by using this method. And here you can see is the value is 38. 38000, etc. Okay, here there are some variation. You have see 4 bedroom, 4,000 square feet, and 2 years old. We can 4,000 years old, 4,000 square feet, and 4 bedroom, and 2 years old. But we have to give a value. This value and this value and already trained value have some variation, some differences. You can see here, right? Right, this is the error. This is okay. You heard about back propagation algorithm? Back propagation.
No, they are going to learn about their propagations.
Okay,
Yes.
fine. Okay,
Go
this
on.
is okay. The problem is that here the variation is that I only use only the 5 data. Okay, if data is increasing, if data is thousands or 10,000s like that, we have to get the accurate result. According to increasing the data set, the accuracy of the algorithm will be increased. Hope you clear my point.
Yes, can I explain that?
Okay.
So what he's trying to say, how about this, whatever that he has done so far, he has done the prediction. So how about the result that he caught compared to the results which are available on the data set? What formula the value that was supposed to be predicted was this number, but the model predicted your first answer. Do you understand that? So which means that there is an error. So to correct that error, you have to use what you call the back propagations. That the prediction should be accurate. That's what he's trying to explain. Is that clear?
Yes.
Perfect. Yes, you can continue.
Okay, then okay, the model analyze the pattern. That pattern we can also analyze the increasing of area. We can price is increasing and number of bedrooms is increasing. The price is also increasing. Age is decreasing. The price is increasing. This is the pattern of this data set. You identified. We are already identified. The same pattern is already same pattern is catch this model. Okay, then training is done. Then I have to predict some. Okay, I will give some 7,000 square feet, 7,000 square feet and 5 bedroom and 3 years old house. Okay, just I have running here, sorry. Okay, just okay, you know, all already this okay, here we can see, sorry, no, 1 second, we can see. Okay, I want to run from beginning onwards, just second. This you already did. Okay, just second. Okay, just second, just second. Okay, just leave this. I will explain. Okay, this algorithm is, oh, just 1 second. I will take once again. Just a second, just wait. Okay.
So what he has done so far, he has used that data to train the model, right? So the model has learned the patterns on the data. If it's the area, the pattern of the area, higher class of increase. The pattern of the age, higher class increase. Do you understand that? So it means the model has learned that pattern. So now, because he has already trained the model, what he has to do now,
Okay.
he has to use different data to test. Now, if I give this model, is it going to predict the value for the type of the data set from an account? You understand that? Yes, that's what he's trying to do now.
Okay,
Yes,
sir, I have some local host error is here. Okay, what I want to say is that according to that pattern, we can predict the new data. We can predict
yeah.
that new value. Please explain to him, to them. Sorry.
Yes, what he's saying is that according to the data that was given, that's what I have already explained. You can be able to use data to predict the new value because the model has learned the patterns from the previous data. Now the model can use whatever that it has learned to predict the new value. That's what he's explaining. Yes.
Okay, fine. Okay, just a second. Okay, okay. Okay, I want to back to my presentation. Okay, just a second. I want. Okay, why? Okay, can okay, my system is got stuck. I think my. Okay, sorry. I am first time using this platform. That's why I can't. Okay,
You
I
can,
can.
yeah.
I can
No,
exit from screen sharing. I'm using the first time this platform.
yeah, no problem. I can see
Uh,
that you have shared the screen now.
okay, but
You
okay,
have shared
okay,
the screen
okay,
now.
okay. I hope you clear the linear regression and multivariate regression. I
Yes,
hope you
perfect.
clear. Okay, you
Well,
hope you
well
all
presented.
clear. Okay.
Yes.
This is the end of my class, and this is a very basic session. Okay, we have to understand. We have to understand. We have several lot of algorithm. The all algorithm is doing is that in supervised and unsupervised, whether it is reinforcement. Okay, all algorithm is doing is that to identify the pattern and to identify the pattern to automate the machine. Okay, machine learning is no nothing about to automate the machine. Okay, natural. Okay, we have okay 1 second. Okay. We have several branches in artificial intelligence. Okay, we have okay. When I am working with speaker recognition. Okay, my research area is speaker recognition. Okay, this is also a part of machine learning. Speaker recognition, I am trying to catch the mimic voice, identification of mimic voice. That's my area. That's also a machine learning application. I want to identify the mimic voice. Okay, whether the voice is real or not by using some machine learning model by identifying the something lot of physics is there. Okay, I just trying to say that there are several areas in machine learning. You can see AI camera. We can identify the dead bodies. Okay, unidentified dead bodies by using AI. Okay, I have a project in here Kerala Police. Philip sir might have know about that project. We want to our project is that identify the unidentified or missing persons or unidentified dead bodies by using convolutional neural network. Okay,
Oh, okay.
the project is that to identify. Okay, we have some any accident death or any other kind of death. We have scratches in our face. There is a the cannot identify it's very properly. Then by using our algorithm we can scan that person's image and we can catch that. I already told that we can catch the face values from that person and it can be identified by using the police database. That is how my project was in my PG. That's a very good project. And there is a several cases in USA. There are several cases that proved by using AI technology. Recently, I read a news in USA that AI caught a thief by using AI cameras by identifying the face of his past face and his new face. Identifying the you must notice is that when we are in small age while we growing up, the uh, face value doesn't change. The face value is always same. We can identify the persons from by using the face value. The face value doesn't change by we are moving elder. Okay, that's according to that in USA there is a case that proved by using this AI technology. The lot of application is there. Okay, you want to analyze the sentiment by using NLP. NLP is also a machine learning branch. Okay, you can okay in Amazon you might have used Amazon, Flipkart, etc. Oh, sorry, Amazon other shopping material. We want to predict a sentiment according to sentiment for a product. Okay, suppose I give you a simple example and I want to come wind up here. Okay, I will give you a simple example. Okay, there you have bought a product like any product, electronics product or etc. We have you can you take you look for the review of that corresponding process and you can read that review and you can analyze that is a good product or bad product by analyzing the review. Is it right? Is it right? Hello, we can analyze that product is good or bad by using the review of according to that product.
Yes, perfect.
Yeah, okay, okay.
Good.
That okay, we can classify that product. Okay, when I am okay, I am reviewing a product like okay, this is a good product or this is amazing, this is bad or this is very disgusting or this is wonderful. Okay,
You
we
guys
have
give your
in
signature, not please.
we
Yes, you can
have
continue.
in there is we have positive class and negative class is there. We can classify the positive review into one class by using our algorithm and the negative words in another class. Then we can conclude that product is good or bad. This is also in current technology. We have several applications and in our machine learning. Okay, this is a simple and very basic part. Not okay. The machine learning is wide area and a largest technology in current scenario. Current scenario, machine learning has very important, very job scope. Very there are various scope in machine learning. There are various branches in machine learning. Okay, etc. In conclude, in summary, machine learning is very important. Machine learning, you have to catch the each and every mathematical or modeling everything in there are lot of area everything in machine learning. Okay, you can go in business analyst by using business analyst, or you can do data scientist, you can do other job, everything under the machine learning. Okay, okay, every business they have done in nowadays is by using machine learning algorithm. You okay, simple example, we I am searching a product in Amazon, at the same time that product is suggested to my social media account. You might have noticed that. Just I am searching my okay laptop for something in Amazon. Okay, in my Instagram page, at that same time the company Amazon suggested several laptops related to my searching. They identify my pattern, they identify my interest, they identify my taste of pattern, then suggest. That is called a recommendation system. I already told you in beginning of this section, recommendation system is example of machine learning. Okay, whether you have youtube, you search some videos, you can recommend a related videos in YouTube. That is also recommendation system. They catch your time or your money by using recommendation. This is also very good business. This is a business intelligence. Machine learning have played a major role in business in nowadays. That's my session. Hope you all understand, and thank you for giving an opportunity, my brother, my friend Philip sir, and I very enjoyed this session. Thank
Wow.
you. Thank you.
Thank you so much, Mr. Babu. That was great,
Thank-
and really enjoyed your teaching. This is so perfect. So, what's the time there?
Thank you.
What's the time
Here
there?
is 6 p.m. 6 p.m.
6 p.m.
6 p.m. now.
You are about to sleep now.
No. I am about to go some outside for enjoy. No. Yeah. Chill
Okay.
out.
So
Okay,
maybe we
okay.
can invite you maybe for dinner. How about that?
Sorry.
We want to invite you for dinner tonight.
Oh, yeah. I want to invite you to dinner here. So
What do you say?
you to here. You're always welcome, and you're always welcome. What about Kerala? You should say about Kerala to your students, and you must
Yeah, no,
visit here from with your students in Kerala. Always welcome. I always welcome. You are
yeah,
my
I'll come
yeah.
there. I'll
I
come
was
there.
I was
No
en- I
problem.
was I was enjoyed that time with you in our university. You should share our
Yes.
experience in university to students. Okay.
Yes. Before you go, can I just show you my students here?
Okay, fine.
No
Yeah.
issue.
I want.
No problem.
Okay.
Let me just connect them so that at least you can see them.
Okay,
People you
fine.
have been talking to.
Okay.
So great.
Okay.
Let me do that. They are
Okay.
hiding themselves, some of them. I was telling them that you're not married. Maybe you can get a girlfriend. No issue. How about that?
Okay. I love South
Yes.
Africa.
So let
Cool,
me let me show
cool
you that.
person, cool persons like you.
Let me show you that.
Okay.
Yes. Yeah, my
Okay.
students in the lab.
Uh, okay. Hi to everyone. Hi to everyone. I hope you all enjoyed. I hope you all enjoy. Sir, could you please share a screenshot of this session to me?
Oh yeah,
Could you
perfect.
please? Okay.
Yes, it was the signal. No problem.
Okay, fine. Okay. Then
Yes, good.
I think we have to time to wind up here. Then thank you for giving it this opportunity to me. Thank you, Philip, sir. Thank you. I
Thanks,
very
brother.
glad to I very pleasure to take a session to your students, especially your
Excellent.
students. Yeah. I
Great.
really enjoyed. I really enjoyed. I want to see
Yes.
your face. I long time no see, man. I want to see your face also.
Want to say
Yeah, long time no see.
this is
Okay,
me. Yes.
Yeah, we have
You can use your machine learning models to identify me when
identify.
I'm using
Yeah,
my
mask
yeah,
normally.
that's
Yeah,
great.
that's an application.
Yes.
That's also an application.
And you
Mask
need to
we can
install that
identify.
application maybe in your
Yeah,
brain.
yeah,
So
we
that when I
can.
put the mask, you can be able to identify my face
Yeah,
based
man.
on the
That's
previous
our
data that we have.
previous data. Okay, fine. Okay.
Perfect, brother.
Okay.
Sure.
Perfect.
Good.
Okay, fine. Okay. Thank you. Yeah.
Thank you.